Hi scholars, today you're going to be looking at evaluating the reasonableness of sums and differences using benchmark fractions, and this is TEK 4.3F. Now if you don't know what a benchmark fraction is, it's understanding where a fraction is on a number line or about how much of something that you have. So we're going to understand where these fractions are on a number line, but then also you looking at other fractions and understanding like, okay, is it about here, is it about here, here, or here? So copy all this and then just put your pencil down and watch the video. And then once the video is over, you're going to pick up your pencil and copy notes. So go ahead and copy this. Hi scholars, today we are going to look at TEK 4.3F. It says I can evaluate the reasonableness of sums and differences of fractions using benchmark fractions 0, 1/4, 1/2, 3/4, and 1 referring to the same whole. So this basically means you can figure out the estimation of sums and differences of fractions using benchmark fractions. So benchmark fractions mean is you have an idea of what 0 is, and that's basically nothing, or close to 0. You could have just a little bit. 1/4, this is 1/4 right here. 1/2, 3/4, which you're going to need 3 of these, and 1 whole. Okay, and right here I have set up my fractions because I do not have an extra fourth to show this. Actually, wait, I do, sorry. I want you to look at this so you have an idea. So this is nothing. This is 0. 1/4, 1/2, 3/4, and 1 whole. We are going to look at a bunch of different fractions and decide where would it go on a number line, which one is it close to, and then give a reasonable or estimation of where it could be. So some of them will be equivalent, like I might say 6/12, and you know that's equivalent to half, or I might say something like 7/8, which is close to 8/8, which is a 1 whole. So we will look at all the different pieces on how to do that, and I will show you a bunch of different tricks. So let's get started. First thing I did was draw a number line. We're going to call this side 0. We're going to call this side 1 whole. So if I were to say put half on there, which would be this, you would obviously put it right in the middle because half is the middle of anything. It's cutting something in half. So then this 1 whole bar here would be right here. So I'm going to put that right next to that. And I'm going to put my half right here. Okay? Now, I'm going to ask you, where do you think 1/4 would be? Well, 1/4 means it's the first piece out of 4 whole pieces. So you could easily cut this into 4 pieces. That's piece 1, piece 2, piece 3, piece 4. So if this is piece 1, this would be 1/4. So then that would go right there. Obviously, the more you cover onto the number line, the bigger the fraction bar will be because you are getting close to completely filling up your fraction. So if I had 2/4, this would be 1/4, this would be 2/4, which is equivalent to half. So then this would be 3/4. So then I'm going to just stack. I hope it'll stay. It's going to actually end up covering it, but that's okay. And so this is called benchmark fractions. You have an idea where 1/4 is. 1/4 is between 0 and half. Half is halfway between 0 and 1/2. 3/4 is between 1/2 and 1/2. These are benchmark fractions. You have to know where they belong on the number on a number line, because when we talk about other fractions, we need to know where those other fractions would go and what are they close to. Benchmark is like an idea, a general idea of where things could be. So let's start looking at some examples. First thing I did was draw a number line. We're going to call this side 0. We're going to call this side 1/2. So if I were to say put half on there, which would be this, you would obviously put it right in the middle, because half is the middle of anything. It's cutting something in half. So then this 1/2 bar here would be right here. So I'm going to put that right next to that. And I'm going to put my half right here. Okay? Now, I'm going to ask you, where do you think 1/4 would be? Well, 1/4 means it's the first piece out of 4 whole pieces. So you could easily cut this into 4 pieces. That's piece 1, piece 2, piece 3, piece 4. So if this is piece 1, this would be 1/4. So then that would go right there. Obviously, the more you cover onto the number line, the bigger the fraction bar will be, because you are getting close to completely filling up your fraction. So if I had 2/4, this would be 1/4, this would be 2/4, which is equivalent to half. So then this would be 3/4. So then I'm going to just stack. I hope it'll stay. It's going to actually end up covering it, but that's okay. And so this is called benchmark fractions. You have an idea where 1/4 is. 1/4 is between 0 and half. Half is halfway between 0 and 1/2. 3/4 is between 1/2 and 1/2. These are benchmark fractions. You have to know where they belong on the number on a number line, because when we talk about other fractions, we need to know where those other fractions would go and what are they close to. Benchmark is like an idea, a general idea of where things could be. So let's start looking at some examples. Let's start with 1/8. So when you put it here, you notice that 1/8 is less than 1/2. So obviously if I try to put it here, you know 1/8 doesn't belong here, it doesn't belong here, it doesn't belong here. I notice it is smaller than 1/4. So 1/8 probably goes around there. In fact, 1/8 is half of 1/4. So I know 1/8 actually is going to go right there. And I can prove it. If that's 1/8, then this must be 2/8. Then this must be 3/8. This is going to be 4/8. And that's true because 4/8 is equivalent to half, so I know I'm doing this correctly. This would be 5/8. 6/8 is equivalent to 3/4. 7/8, and then obviously 8/8, which is equivalent to 1/2. Okay? So hope you're getting an idea of how this is going to work. So when someone says 1/8, what is that about? It's close to 0, but it's also close to 1/4. So you have an idea where it could be. Suppose someone gave you something like 1/12. If you notice, 1/12 is smaller than 1/8 size-wise. Okay, so I know 1/12 is somewhere here. So then I have 2/12, 3/12, 4/12, 5/12. I know this would be 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, 12/12 would be right here. I'm not worried about labeling the entire number line. I just want you to see a general idea that 1/12 is so tiny that it is very close to 0. So it's like saying I almost have nothing. Okay? If I had 12/12s, or actually let's look at it differently. If I had 11/12s, I'm going to grab all my 12s. I'll show it to you in a second. If I had 12/12s, or sorry, if I had 11/12s, I am very close to 1 whole. Do you see that? 11/12. So if someone said, what is 11/12 about? I'm going to say it's about 1 whole. Let's just estimate that it's right around here, 11/12, because it almost filled the entire bar. So 11/12 I could say is close to 1 whole. But if they said 1/12, I'm going to say it's close to 0. I hope this is making some sense. What if I said 5/12? 1, 2, 3, 4, 5. I'm going to move those pieces here. If you notice, 5/12 is very close to almost being 1/2. So it is safe to say 5/12 is about 1/2. That's a benchmark. That's a reasonableness. Okay? So let's look at some addition and subtraction questions someone could ask and help us determine what the answer could be. Alright, now that you've watched the video, I'm going to show you, I'm going to write some notes and you're going to copy them in your journal. So, you should have seen in the video where these fractions fall. So, if you have a number line, you know 0 and 1 are right here. And you know the halfway mark is right here. Okay? Now, fourths and 3/4, if it's 1/4, then the thing has to be cut into fourths. So, you're just going to add 2 more lines, and if you remember me talking about counting the hills, 1, 2, 3, 4. So now this thing is cut in fourths. So this is 1/4, this is also known as 2/4, and this is also known as 3/4. So those are fractions. You have to know where they are on the number line. You should know that it's 0, and then 1/4, and then 1/2, and then 3/4, and 1. You should also know that 1/4 is less than 1/2, and 1/4 is actually half of half. So like if you were to just look at this side, 1/4 is right here. That's halfway between 0 and half. So that's that. And then 3/4 is halfway between half and 1. Okay, so let's just look at a bunch of different fractions and where they would belong. So let's say we had like the fraction 11/12. Okay, so I don't want you to cut this up into 12 pieces. The whole idea of benchmark is you can automatically kind of tell me, I know it's close to this. So if you just kind of imagine, well, this is 0/12. The equivalent to 12s over here would be 6/12. Okay, you can kind of make some notes. You can tell yourself, well, that's 0/12, that's 6/12. This has to be 12/12, which is 1 whole. Well, we have 11/12. So this would be somewhere around there. So 11/12 is about 1 whole. 11/12 is about 1 whole. Because if 12 is the total and 12 out of 12 is 1 and you're only one little piece away, you're pretty much close to that. Okay, let's look at another one. So let's look at 1/16. Okay, you can think about, well, this is 0/16. This is 16/16. Halfway would be 8/16. So if I only have 1 out of 16, and that's 8 and that's 0, I'm somewhere over here. Okay, so this is kind of basically nothing. I mean, it is something. It's not exactly 0, but you know it's barely anything. You're on this side of the number line. Let's look at another one. How about 6/10? Okay, I know that this is 0/10. I know this is 10/10. And I know the halfway point is 5/10. So 6/10 has to be somewhere around there. So 6/10 is close to half. Because remember, these are our benchmark fractions. This is what we are deciding that it's close to. So 6/10, which is right here, is about 1/2. Okay? We're going to look at a few more. Actually, I'm going to just scoot over to this side of my journal now because this is just getting really cluttered. So I'm going to just make a new one. Okay. Now you guys are going to be starting something called Countdown to Star, and there is a question on your countdown where it's benchmarks using reasonableness of sums and differences, and on your on the side where you're supposed to show your work, it says try showing the fractions on a number line. So you will have this drawn out, and so you are expected to kind of fill in the benchmark fractions and then decide where that fraction goes. So we know that's 1/4, and we know that's 3/4. Okay, so now let's look at how about 20/30ths. That's a big stretch. That was a huge example, but let's go ahead and look at it. So 20/30ths, we know this would be 0/30ths. This will be 30/30ths. My halfway point will be 15/30ths. So I have 20/30ths, which means it's not close to this, but it's not right before this either. So you kind of want to think about, well, between here and here it's about 15, and 20 is like 5 away. So actually, you know what? I want to change this to 25/30ths. Okay, so 25/30ths is kind of like in this area. Just kind of estimating. I know it can't be close to this because this would be 16, 17, 18, 19, 20, and this is 29, 28, 26, 25. So somewhere around here would be 25/30ths. So this is about in the 3/4 range. Okay, I don't want to say it's equivalent, but it's definitely not half, and it's definitely not 1 whole. You could say it's 1 whole. It's close to that too, but I just wanted you to see an example over there. Okay, let's look at another fraction. How about 8/18. Okay? So this would be 0/18. This would be 18/18. So halfway mark would be 9/18 because 9 is half of 18. So if I have 8/18, I'm right about here. So this is about half. Okay? Let's look at one more. I'm trying to think of an example that would put the fraction around the 1/4 area. Here we go. Here's a good one. 7/24. Okay? So 0/24, 24/24. This would be 12/24. That's the halfway point. So 7/24 falls in right here somewhere. It's not 1, 2, or 3, so it wouldn't be here. But it's not like 11, 10, 9 that it would be here. So I want to say 7/24 kind of falls around that range. So it's about 1/4. Okay? So there's several examples of different fractions that you can decide what it's close to on a number line. Okay, so I wanted to actually just go over a question that's on your countdown so you have an idea how to solve it. Colton estimated the sum of two fractions. 15/16 plus 7/16 is about 1 and 1/2, or 1 and a half. So estimate means, guessing, giving a good estimated, a good educated guess, and sum is addition. So he's putting two fractions together, and he's saying this is about 1 and a half. Is this reasonable? Is this good what he said? Is this correct? Does it make sense? So what you do is you're going to take each of these and put it on a number line. So right here I wrote, try a number line, show 15/16 here. So what you would do is you would be like, okay, well, there's my benchmark fractions. I know my benchmark fractions. So this is 0/16. This is 16/16. The halfway point would be 8/16. So 15/16, well, that's like right over there. So 15/16 is about 1, okay, because it's close to that. It's not any of these. And then it says show 7/16 here. So same thing. Set up your benchmark fractions. Okay, same thing, 0/16, 16/16, 8/16. So 7/16 would be right about here. So 7/16 is about 1/2. So when you add 1 and 1/2 together, it's 1 and 1.5. And that's what he's saying. So is this correct? Yes. Okay. Now, you also have to pick the answer that explains it correctly. So I know the answer is yes. So I know H and J can't be it. Okay. Yes is the first part we're looking at. Now, because 15/16 is close to 0 and 7/16 is close to half, well, we said 15/16 is close to 1. They're saying close to 0. So that part of the reasonable or reasonableness is not correct. G, yes, because 15/16 is close to 1, yes, and 7/16 is close to half, yes, that's what we discussed. So you would pick G as your answer for benchmark fractions. All right, we're going to look at a question in your Go Math. One day, 3/8 of the students in Jack's class ate toast for breakfast. Another 1/8 of the students ate oatmeal. Jack added the fractions and found the sum was 7/8. Which statement best describes the sum 7/8? So he added 3/8 and 1/8. Okay, and he's saying it equals 7/8. Now, we know that's not correct. We know 3/8 plus 1/8 equals 4/8, but just, work with me here. So 0 and 1, and then 1/2, okay? And then there's your 1/4, there's your 3/4. So we have to put these where they belong. So for eighths, 0/8, 8/8. The first one is 3/8, or hold on, halfway would be 4/8. So the first one is 3/8. That would be right around there. Okay, so it's about half, I want to say. And then 1/8 would be right around here. So that's like 0. Okay, so we know that when you have about half plus about nothing, half plus nothing equals half. Okay, so looking at this, is his answer 7/8 reasonable? It is reasonable because half plus 0 equals half. Well, 7/8 falls right around here, and that's practically 1. So they're saying their answer is about 1, but we got half. So we got half plus 0 equals half, but they're saying it's reasonable what he said. So that can't be it. You have to be careful with these because there's 2 parts in every answer choice. It is reasonable because half plus half equals 1. Well, we said half plus 0. So, and it's not reasonable what Jack said, so that can't be it. It is not reasonable because half plus 0 equals half. That sounds possible. It is not reasonable because half plus half equals 1. Well, we know it's not reasonable what Jack said, but our reasoning is half plus 0, and their reasoning is half plus half equals 1. So it's gotta be